Okay everyone, welcome back. Up to this point, we said that when it comes to using electrical symbols, we can work based on some specific standards. For example, IEC, and we also mentioned an American standard called NEMA. And, well, we've actually seen some of these American symbols as well. For example, this was the American symbol that we would use for overload relays. Then also the contactors. The contactor alongside its bobbin and its contacts. Then the start button, for example, or the stop push button. Normal open contact, and also normal closed contact. Now let's take a look at a circuit containing these symbols. All right. First off, guys, when we are working based on this specific standard, we should know that we don't have any lines representing null. And also, as another point, most of the sketches in the electrical diagrams would be set horizontally. All right? Now, here we have three phase lines, L1, L2, and L3, which are connected to contactors, and the contactor is being connected to overload relay, and overload relay or the bimetal would be connected to the motor. To the terminals that we have, T1, T2, and T3. And we also have a control circuit here. First off, the control circuit is being fed up by two of the phase lines, like, for example, here by L1 and L2. And also, guys, another thing that might actually catch your eye would be the order of setting the equipments. If I want to elaborate here, the order is actually different from what we used to see in IEC standard. For example, the stop push button is set here, and on this side we have the bimetals or the overload relays normal closed contact. And you can also see the terminals 95 and 96. Here we got the contactors bobbin, then the start push button, and then here we have the contactors and its contact with numbers 13 and 14. Let me write it down. So guys, the circuit that we had before was kind of like this. Like we should have a fuse. Let me set this here as the fuse, then the normal closed contact of the bimetal, after that the stop push button, then the start push button, after that the bobbin, A1 and A2, and the null. And then here, contacts with numbers 13 and 14. One difference that is quite obvious is the fact that this diagram here is actually vertical. But here in the American version, or NEMA, it is set horizontally. And also, some of the equipments are set in another place, but this isn't a big deal. Okay, now let me move to this slide. All right. Now, guys, before we start talking about our next circuit, first, let's have a discussion on MCC switchboards. All right. So let's see what we have. There's a three-phase motor's starting circuit that is set inside of a panel, and the panel is actually has this drawer shape. So, in other words, all of the equipments here are set inside a drawer. Now, when we draw the panel out, the circuit would actually be disconnected. And also, in the backside, the backside of the panel or this drawer, we have some connections through which the panel would be connected to the three-phase motor or three-phase lines. All right. Now, guys, let's go ahead and take a look at the interior circuit that we have in this electrical panel. Well, actually, by looking at it, let's try analyzing it. All right, take a look at this, guys. Here we got a diagram of an electrical circuit from one of those electrical panels, draw out electrical panels. It is called MCC wiring diagram. And by the way, guys, MCC stands for Motor Control Center. Now, first off, we have the phase lines here. And through the connections that we would have, they would be connected to the breaker that we have. And the breaker could, for example, be MCCB breaker. Then after that, the breaker would be connected to the contactor. Then from the contactor to the overload relay. And at the end to the three-phase motor. Now, guys, as we previously mentioned, we can use two of the three-phase lines like L1 and L2 for feeding the control circuit. We'll get an incoming voltage from these two lines, L1 and L2. Then here we have two fuses, but we can also use one. Then right after we have this transformer, a decrescent transformer, which decreases the voltage for feeding the control circuit. All right, now as you can see, there's another fuse here. And then everything is connected to the control circuit. Now, regarding the circuit itself, the control circuit itself, we have this stop push button. And, well, it is actually quite the same as before. We have the start push button after that. And then here we got the contactors button. And here we got the bimetals normal open contact. And again, the same numbers as before, 95 and 96. Here we got the normal open contacts of the contactor with the same numbers as before again. 13 and 14. And they are connected to the start push button. We also have some signal lamps, guys. When the contactor starts working, these lamps here would be turned on. Okay, and we also have another signal lamp set up here on this line. And if the contactor was turned off, or if it was diffused, for example, this contact here would work, and this makes the signal lamp to be turned on. And if the contactor was activated again, the contact here would be opened, and as a result, the signal lamp would be turned off. Now, guys, remember, the signal lamps and also the push buttons, talking about the start and stop push buttons both, they are all set on the exterior part of our electrical panel. Talking about the front part or front panel of the unit or the drawer. And, well, here you can see all of their electrical symbols, for the signal lights and also for the start and stop push buttons.